Today we're going to talk about one more theorem, and that theorem is going to help us use those congruent triangles to do more. So first of all, we have a theorem called Cpctc, which is an abbreviation. It's going to save you a lot of writing. And that theorem says that two triangles are congruent if and only if their corresponding parts are congruent. Biconditional statement. That IFF is an abbreviation up there. It's not a typo. Two triangles are congruent if and only if their corresponding parts are congruent. Which means that if the corresponding parts of two triangles are congruent, those triangles also have to be congruent. Works both ways. And Cpctc stands for corresponding parts of congruent triangles are congruent. Corresponding parts of congruent triangles are congruent. We only get to use this theorem after we get the triangles congruent. Okay? Have to have the triangles first, then we can say that the parts are congruent. Okay. So the first problems that you'll be working on today for your assignment are similar to this one. Can we say that segment AD is congruent to segment R or BC? And if so, how? So the first problems that you're working on today don't require a full formal proof. Okay, you're not going to be writing out a 2-column proof on them. What you'll need to do for those problems is to copy the drawing or trace it out of your book. Okay, mark it up, and then figure out if the triangles are congruent. Tell me if so, why. Okay, what theorem gets you there? And then the parts themselves can be congruent by Cpctc. Okay? So we're looking for AD to be congruent to BC. Okay? A little bit of some notes. Okay? We'll get there. Okay? So we have two sides that we want to know if they're congruent or not. In order to get them congruent, unless we have something, we've been told something, we have to first get these triangles congruent. So I see a pair of sides that are congruent, right? Excuse me, a pair of angles that are congruent. When we have two angles of one triangle congruent to two angles of another, what's the other part that we have to get? They share a side. Okay? So I'm not asking for a formal proof today. I'm asking you to, and at least in the first problems, I'm asking you to draw the figure, show me what you can, whether it's a reflexive, they share the same side, or there's some vertical angles that you can mark. Okay? And then tell me that those triangles are congruent. So Nolan, would you please give me the name of this triangle? Any order you want. Okay, first name this triangle for me. Any order you want. ADC. You said which one? Okay, ADC you started with. Okay, So Nate, if ADC is how Nolan decided to name the bottom triangle, how do we have to name the top one? You started with A, which has no mark, and went to DC, so we have to start with C and CBA. Okay? Bless you. So these two triangles are congruent. Why are they congruent? Angle, angle, side. Why is it angle, angle, side, not angle, angle, side, angle? Side's not in the middle. It's not the included side. Okay? All right, we've got our triangles congruent. Now we can say that the parts are congruent. AD is congruent to BC by Cpctc. Corresponding parts of congruent triangles are congruent. Okay? Make sense? So, not a formal proof. Did you see two columns with statements and reasons here? Nope. I want you to draw the drawing. I want you to make the marks. If it's something easy like reflexive or vertical, you don't even have to write it up. Just show it in the picture. And then tell me the triangles are congruent and why, and that the parts that you're looking for are congruent by our new theorem. Okay? Okay? Next slide. Draw the picture. Yeah, we're going to prove this one real quick. Okay? So draw the two triangles. I do. Mm-hmm. So first steps always, write your givens. So I've got my givens written down. Next step is always, always, always to mark up your drawing. Okay? G is congruent to N. Here's angle G, here's angle N. Make your arcs. Okay? Then ask yourself, what else does the given mean? HK bisects angle GKN. GKN. What does it mean if HK bisects it? So these two angles are going to be congruent, right? So let's name the angles. More than one angle at K, so we can't say K. Definition of bisector, right? Okay. And then someone already said HK is in both. Write it down. Why? Anytime something's equal to itself, it's reflexive. Okay? So John, name the first triangle for me, the top one. Any order you want. KGH. Nolan, if John called it KGH, how do you have to name the next one? Started with K. He said KGH, so you have to say K and H. What's our reason? We have two angles and a side, so which one is it? We have two angles and one side, so which one is it? Why is it AAS and not ASA? Two angles and the non-included side, right? Okay. And then finally, we can say what we're trying to prove. GK is congruent to NK. GK congruent to NK by, what's our reason? What's our new theorem? Okay. So the process is always going to be get the triangles congruent, then the parts are congruent by Cpctc. Been doing it for years. Okay? Everybody good? You need to see another one. Pretty easy, right? Same thing we've been doing, just add this extra step, Cpctc. Okay? So assignments on the board.